Hi everybody and welcome to today's episode of New Breakpoint. My name's Simon Waite. We're in for a treat today. If you want to join in today's show, please make sure that you either hit us up on our Twitter handle at Microsoft AU Dev or join us on YouTube where you can add live comments while we're live streaming today, and they'll be brought into the studio so we can actually answer them for you while we're broadcasting. Make sure you hang around for the end of today's show as well, because we've got a great prize giveaway. It's not about today's show. There's a bit of a challenge involved in it, but you'll have to hang around to find out a bit more about that. As always, please make sure if you're collaborating with other people in our community that you have a read of our code of conduct to make sure that when you do engage with other people, you're doing so safely and respectfully. All right, so let's get on with today's show while I can get up to here. Our main guest for today, this is a really interesting space. If you're a developer, you've probably heard about DevOps a lot over the last five or so years. It may be something that you're doing today, it may be something that you're adopting. But you've also probably heard a lot about machine learning. Maybe you are doing that as well, maybe you aspire to do that. A challenge that machine learning has, that software has had for many years, is that you've got a large amount of artifacts, you're creating a large amount of things when you're doing machine learning. How do you effectively manage the life cycle of those artifacts and, in fact, the long-term delivery and management of machine learning, generally speaking? So today we're lucky enough to have Damian Brady, who's a senior cloud advocate here at Microsoft, joining us to talk about machine learning ops, or MLOps, which is a space that he's passionate about and one that he covers quite a lot. So let me just bring Damian onto the stream here. Hi, Damian. Good morning. Hi.
Morning. How are you?
I'm doing well for a Thursday. How's things with you where you are in Australia?
Pretty good. I'm a bit north of you. I'm in Brisbane, so it's pretty typically about 30 something degrees Celsius. During the day, so a bit warmer. But I've got aircon on, so I'm good.
And I know this is a space for you. MLOps is a space for you that I've seen you talk about it before, and I know it's an interesting topic because, as I said up top, that machine learning specialists, data scientists, they don't really come from that traditional software development background. So the idea of structured management of machine learning artifacts during the early stages of development and the later stages of running these things in production, it's a new space. And I think, as we've said in the show notes, there's a lot of opportunity here for developers as well, potentially, to use this as an entry point into the world of machine learning. Do you see that as something that comes up a bit in the talks that you do?
Yeah, definitely. Whenever I talk about it, I seem to be talking to one of two audiences. It's either the developers looking to get into machine learning, or data scientists and ML experts who are looking to kind of formalize and mature the processes of getting the predictive models kind of working in production and things like that. There's, like you suggested, there's not really always an overlap. I mean, data scientists generally aren't developers. They might write some Python and R and whatever other code they use, but they haven't been in that kind of environment with a team of 30 developers doing sprints and delivering a project at the end of the month and stuff like that in a collaborative sense. That's a relatively new thing for that area.
Mm-hmm. So I know you've got some things to share with us today. So if you want to go ahead and just pull up your screen so we can add it to the stream here, and then I'm going to hop out of the way and let you get on with this great topic.
Yeah, for sure. So let's just jump into this. This is kind of where I want to start.
See you guys later.
Hide that little thing. Hide. Cool. This is pretty much where I want to start. So I come from a DevOps background. I've been a software developer for 20-something years, which means that I've always been in that kind of area where I'm writing the code, and then all of the surrounding stuff around DevOps and Agile and all of that kind of thing. It's meant that I've moved into DevOps, and I've been doing that for that kind of thing for longer than DevOps has really been a word, to be honest. The surrounding parts of getting an idea into production, essentially. So this is Microsoft's definition of what DevOps is. It's a union of people, process, and products to enable continuous delivery of value to our end users. And when I kind of moved towards the MLOps stage, I kind of went through these phases of thinking, oh, well, it's just DevOps for machine learning, and then rethought it a little bit and thought, well, actually, maybe there's a lot of differences with the way that machine learning works. So maybe we can't just apply DevOps blindly. And I've come to somewhere in the middle now after, a couple of years of looking at this, where I think there's parallels with a lot of the ideas, or almost all of the ideas of DevOps. So I kind of think of MLOps as DevOps applied to machine learning projects. So this definition here, by the way, union of people, process, and products to enable continuous delivery of value to the end users. I've highlighted the word value because that's, in my opinion, the most important part of this definition. And it means that this definition doesn't have to change when you're talking about MLOps. Because if you have a predictive model that's in production, providing, predictions for what people might like to buy, or, whether somebody's going to be approved for a loan or something like that, anything along those lines, if you can improve the accuracy of that model, which is really what this whole ML exercise is about, then that's going to provide value to your end users. So this fits. It's not code that you're delivering to production or features or anything like that. It's value. So from that perspective, MLOps is simply DevOps for machine learning. Now, there's obviously some differences. So when you think about a continuous integration, continuous delivery scenario for traditional software dev, you end up with a build that might take a few minutes if it's a bit slow, maybe up to an hour. I've been in organizations where the build takes quite a while. But you're really talking, in the minutes. For a predictive model, like a really large, complicated one that's running in production, you may be talking about a day or so using really, really expensive machines in the cloud to do that training. So CI, like every single time you make a change, running through that entire training pipeline doesn't really work. There's a lot more data involved. There's a lot more processing involved. And so this continuous building of your predictive model doesn't really work in a clean way, the same way as traditional software development. But that doesn't mean the concepts can't really apply. So having automation that's kicked off when you change your code by GitHub Actions or by Azure pipelines or whatever tool you use, that orchestration can still happen, but you probably want some other tool to actually do the training. So this is that's the first part of it. We're doing our training, and then we're ending up with this artifact ultimately. Maybe you're not doing it on a continuous basis, but when you've done a training run of a subset just to prove an idea, and then you're like, okay, well, now we'll actually run that training over the next couple of days or something. Now, what do you do with that predictive model? And here's where it gets very, very much aligned to what DevOps is, where we want to deploy it to production in a safe, repeatable way. And we want to do it in a way that enables us to kind of roll back quickly if necessary, or verify that this version is actually providing better value than the version that's in production. And we're talking about, feature flags around which predictive model we use, or deploying to a test environment and running some tests on it first, or doing some canary deployments or A/B testing or something like that. And this is what DevOps is already really good at. We've got a lot of history around doing that kind of thing for production systems. So in general, DevOps is kind of very much aligned, but I think it's worthwhile making sure that you're aware of what the differences are when it comes down to the actual day-to-day work, and the limitations and the differences between the work that actually happens. So jumping ahead a little bit, I tend to use GitHub Actions for all of my CI/CD, but as I mentioned, that's probably not the right tool for actually running some training, especially if it's long-running, CPU intensive or GPU intensive. So what I tend to end up with is this kind of hybrid pipeline where Azure Machine Learning does the data preparation, the training, the model registration, and that can also be, you can use Spark or anything you use basically as part of your data science projects. As long as you can build a pipeline in that process, kick off the training, end up with a model at the end of it, The orchestration can happen kind of in Azure DevOps in this diagram, or it can happen in GitHub Actions. And I'll show you in a second what that might actually look like. So Azure Machine Learning is a product that's really, really good for MLOps. So for the whole life cycle of running some data prep, some training, comparing algorithms against each other, registering models, having experiment tracking, having metrics being published as you're doing your training, all this kind of stuff is really designed around that MLOps scenario or machine learning training scenario. And even the deployment, you can do that through Azure Machine Learning. And there's some new stuff coming out with that as well in the coming months to make it easy to actually pick up a model and deploy that to production in a really easy way. So I might use Azure Machine Learning to do the training and to create a model, and then Azure Pipelines or GitHub Actions to deploy it to Azure Container Instances, run some comparisons between what's running in production, what's running in my test site, check everything's off, and then promote that to our production environment using that tool that's good for the DevOps side. So this is a really high level of what that actually looks like. If we jump over, so this is Azure Machine Learning Studio. I'll zoom in a little bit more just to give you everything. And this is really, really fully feature complete here. We've got the ability to do notebooks on hosted machines, which means you can do all of your experimentation and stuff with Jupyter Notebooks. Automated ML gives you the ability to kind of save time when it comes to choosing algorithms or tuning hyperparameters and things like that. It means that you can say, here's a bunch of different parameters around which algorithms or what type of problem it is, and some ranges of hyperparameters. Just go and do a whole bunch of experiments, and then based on whatever I think is the target, what defines success, tune that and tell us what the most appropriate set of settings are. And that gives you a really good starting point for, this is the algorithm I should use, these are the hyperparameters I should use. That'll give me a good outcome. So that saves a lot of that time. There's also a designer which lets you kind of just do this stuff in the UI. And this is a little bit like kind of drawing. If I kind of liken it back to writing your web applications by dragging and dropping onto a canvas. It's great for proving out ideas, but this isn't really shareable with the rest of your team. I'm by no means an ML expert. This took me a few minutes, probably about 5-10 minutes, and it basically just predicts the price of a car. And the outcome I got was not bad for a first pass, with almost no knowledge, just working out how this stuff fits together. So this is really good. It's great for proving out these ideas and for people who aren't familiar with ML. So that's a good starting point for people if you're a dev and not machine learning expert. But then we get into this area down here with data sets, experiments, pipelines, models, endpoints, and even things like managed compute, registered data stores and stuff, which is really focused around the MLOps side. So actually the process of creating a predictive model as you go, and registering everything that happens along the way, keeping track of it, and then ending up with something that is has a history on it. So a model that came from an experiment that came from a set of data, so you can have that traceability end to end. So I'm just going to jump into a couple of these data sets. I've got a couple here. I've got some product images. This is just a registered data set, so it's a connection back to, in this case, an Azure blob storage. In this case, it's tabular data, just based on a URL. So yeah, this one's an open data set, the MNIST open data set. So the advantage of having these data sets registered is, whenever anybody runs an experiment, they're running the experiment against this known data set. And of course, they're versioned. So if we update our data set, our product images, for example, we can retrain based on an older version if we need to recreate a model or something like that. So this is a really important part of it as well, these registered data sets. There's also some really cool features around data drift as well. So so the idea behind this is that you have a training data set that you trained your model on, and then you have a data set for what you're seeing in production. And you can, within Azure Machine Learning, do some statistical analysis between what you're seeing in production and what you trained your model on. And if that drifts a certain amount statistically, that's a good sign that you probably need to retrain your model on this new data. And you can kick off new pipelines automatically as a result of that. So particularly in machine learning, a predictive model that's running in production with real data can get stale when things change, when new products get added, whatever your scenario is. So it's important to know when you need to retrain your model, to have a retraining strategy. So dataset monitors and data drift are really, really handy for that kind of thing. The experiments as well is kind of the core of this. So this is what I've been working on as well. So there's the car price experiments and the MNIST experiments. So these are basically training runs, and you can drill into these and see, here's how long they took, any tags I've added to it, a whole bunch of statistics that I've published, or parameters, sorry, that have been published, snapshots, even things like explanations and fairness of the predictions in there as well. And of course, at the end, we have a registered model that we can deploy if we want. So that registered model as well will have, a bunch of different metrics on it as well, so we can tell whether it's likely to succeed. The product itself is quite deep, and I don't want to go into it too deeply. There's a lot of stuff, especially on Microsoft Learn, that'll get you through, actually trying Azure Machine Learning out. But you can see that that's quite powerful, and I can publish obviously not just the model itself, but any other surrounding bits of code or artifacts that are needed to run it too. So really cool stuff. Pipelines as well is kind of our definition. So we have this car price pipeline that we've got here. And so we can see that pipeline was basically what we drew before, but we can see that when we ran it, we've got these different runs that took different amounts of time, and drill into those and see, what happened and what it looked like and so on. So this is what actually ran as opposed to, what we drew before. Really, really powerful tool. And then finally, endpoints. There's a couple of areas to endpoints. There's these real-time endpoints. So when you actually deploy a model, you'll end up with a real-time endpoint that you can hit. And then also our pipeline endpoint. So when you create a pipeline, you can hit that pipeline to kick it off. So by way of example, I hooked up, I've been experimenting with the version 2 of the Azure Machine Learning CLI that is under development at the moment. It's in private preview. So I'm not going to be able to show you any super detailed bits of code or anything like that. But here's a workflow that I have basically in Github Actions. So whenever I change my code, I will tell Azure Machine Learning to go and do a training run. So in this case, it's just this one stage or one job, and I'm running an extension to add a particular private preview version. But then I can create a job in Azure Machine Learning just by doing AZML job create and giving it some details. And that actually goes to Azure Machine Learning, kicks off a job to run that experiment. And even if that takes a few days or a huge amount of resources, that's okay. I don't have to wait in my GitHub Actions. I can get a callback essentially using some GitHub Actions features like the repository dispatch events. So when that finishes, and you can see I've got a couple of failures going on here, I get this model registered callback. So my Azure Machine Learning training run will create a model and register it to say, this experiment produced this model with these metrics, and then call back to Azure Machine Learning, to GitHub Actions to say, I've got a new model, what do you want to do with it? And that's where we get back into that standard DevOps idea of, well, now let's deploy it to a test environment or to an A/B test or to a canary deployment or something like that. So that's kind of a little walkthrough. A couple of other things I didn't mention here that are really handy with machine learning in the Azure Machine Learning tool. Scalable Compute is super powerful. I am running on a reasonably powerful desktop at the moment with a GPU in it, but if I want to do any kind of training with huge amounts of data or massively parallel compute, then I probably want cloud compute. So this Azure Go example is a compute instance, so a single instance, but I can also do compute clusters. So I've got a cluster here which will scale up and down as I need it. So right now, everything's set to 0, so it will scale back down to 0 nodes. But if I need them, it'll provision for when I actually run that experiment. So I can run, a huge amount of training using very powerful machines, and I'm only paying for it when I'm actually doing that training run, which is really handy as well. There's also clusters for inferencing. So when I'm running it in production, I can get that working as well. And of course, data stores, some tools around data labeling, linked services with Azure Synapse as well, which is pretty cool. So yeah, a huge number of things in this tool for the ML training and deployment stage. But then you might want to use your standard DevOps tools for that lifecycle and orchestration stuff too. Yeah, bit of a run through there.
It's a very broad topic, and I appreciate for a lot of folks who are maybe from a development background, there's a lot of stuff in here that has some familiarity to it, but there may be things that are you look at this and you kind of go, things like linear regression and things like that in model design can be a bit hard to grok, particularly if you don't have a strong mathematical background. But I think the takeaway for me, just looking at the stuff you've talked about today, is there's also a lot of familiarity in here, and there are a lot of ways to bring value to the process outside of just being a deep machine learning or data science specialist. And I think it's only going to improve over time as well, from what I can see.
Yeah, absolutely. And there's parts of this like automated ML and the designer, which are really designed to kind of get you into this area, even if you're not the expert. So, 2-3 years ago, I knew almost nothing about ML. And then basically just speaking to other practitioners and doing Microsoft Learn and a few other courses and things like that, I know enough that I understand what's happening. I probably wouldn't hire me to run your ML projects. I can certainly help with your MLOps stuff, but if you're asking me what the appropriate algorithms to use for particular problems and stuff like that, I'm probably not the best choice.
Yeah.
But this designer was enough for me to kind of put together a predictive model. All I needed to do was really understand how machine learning kind of works.
Yeah. So
it's a really good starting point that they give you in here.
And I saw that diagram that you had with that logical flow had those magical two phrases in it, which was ACI and AKS. The idea that you now, yes, you can use ML Studio, and in fact, you can probably live in ML Studio for the vast majority of the work that you're going to do. However, if you are, an organization that has decided to standardize on a Kubernetes containerized backplane, cloud native backplane, there's absolute value here in using something like Azure Machine Learning Service and then tying it into ACI and AKS, or in fact any Kubernetes deployment ultimately once you containerize your model and the artifacts that go along with it. So huge amount of value in this space. Thanks a lot, by the way, for coming on and doing this. I think the more we talk about these sorts of capabilities with the developer audience, the more normalized it becomes. And to your point, where you're saying 3 years ago this was kind of a very new space to you, I think increasingly through these sorts of activities, we start to understand more and more about this space, and that doesn't devalue the experts in machine learning or data science, because they are absolutely a valuable part of any team building this solution. But I think the more we normalize it, the more we democratize it, the more capability people in the development space will have to deliver solutions using machine learning.
Yeah, absolutely. And remembering as well that this product is kind of the most advanced way of doing machine learning on the Azure platform. So there's cognitive services, and there's that whole range of things that you can just use, hit an API and get some really powerful behavior out of that. But if you are writing your own models, then Azure Machine Learning is kind of that other end of the scale. So
cool, very cool.
Starting from the end.
Look, thanks a lot, Damian, for joining us today. Please hang around. We're going to wrap the show up, so hang around while we go through the next couple of steps. And then, as promised earlier, developers win prizes. And as I said, it's not about Damian's fantastic content today. It's about the show that we did for Microsoft Ignite last week. So if you were one of the viewers that came along, you should already know the answers to our quiz. If you weren't, you're not out of luck, because the show has been published up on our YouTube channel playlist. So if you go to the playlist, you'll be able to watch the episode and find the answers to the questions in our quiz. Unfortunately, Damian, you and I don't have a chance to enter this, but I think the prize, the first 2 people who successfully answer the 5 questions that we've got will win a set of Surface headphones too, which are an amazing set of headphones. Will be delivered to your address here in Australia. Full T's and C's are up on the website as well. So if you go to that link that you can see on the screen and you enter before 5 p.m. tomorrow, if you're seeing this after 5 p.m. tomorrow, sorry, maybe next time you'll have more of an opportunity to join in. If you'd like to find out more about Damian, who he is, and more about the topic that he's covered here today, if you go to our show log at that link at the bottom, you'll be able to find all of the information that's fit to print. So I think we're pretty much it for today's episode. Damian, once again, thanks a lot for joining us today. I'm going to sign off with the usual wave. So you want to give everyone a wave out there in viewerland for a second? Sure. Yeah, all right, cool. So thanks a lot for joining us for today's episode of New Breakpoint, and we'll see you again next week. Thanks a lot, folks.